Next, we are going to look at the reactions of alcohols. And the first reaction is combustion. Like many other organic compounds, when alcohols undergo complete combustion, it forms carbon dioxide and water. So this is a general equation for complete combustion of alcohols, and it can be found on page 6 of the notes. And as you might recall, combustion is actually a very exothermic process, which means that alcohols, such as ethanol, may be used as fuels. The next reaction is nucleophilic substitution of alcohols to form halogenoalkanes. So in the previous chapter of halogenoalkanes and in the previous section, we mentioned that when halogenoalkanes react with aqueous sodium hydroxide or potassium hydroxide, it forms alcohols. So this reaction is the reverse of that reaction. And in this reaction, the hydroxyl group is replaced with a halogen atom such as chlorine, bromine, or iodine. So the first reagents that can be reacted with alcohols to form halogenoalkanes are hydrogen halides. So over here, please take note firstly that these are gaseous hydrogen halides, not hydrogen halides dissolved in water. So when you heat the alcohol with hydrogen halide gas, it leads to the formation of the corresponding halogenoalkane. So if you want to synthesize bromoalkane, for example, you can heat the alcohol with hydrogen bromide gas. Take note that hydrogen chloride, when you react it with alcohols, you also need a zinc chloride catalyst. It acts as a Lewis acid, so it will react with the alcohol to make it more reactive towards nucleophilic substitution. Next, which are phosphorus pentachloride, PCl5, or this compound known as thionyl chloride, SOCl2. Okay, PCl5 is a bit more reactive than SOCl2. So if you are reacting the alcohol with PCl5, you can do it at room temperature. But if you are reacting the alcohol with SOCl2, you will need to heat the reaction mixture. Okay, so notice that for both of these reactions, it produces HCl, which is a gas. And this gas appears as white fumes. So this reaction between alcohol and PCl5 or SOCl2 can be used to identify OH groups, not just in alcohols but also carboxylic acids, but not phenols. Phenols do not react with PCl5 or SOCl2. So the test for identifying OH groups in alcohols or carboxylic acids is simply to add PCl5 or SOCl2 to the compound. If an alcohol or carboxylic acid is present, you will observe steamy white fumes, which is the HCl. Correspondingly, if the alcohol or carboxylic acid is absent, you're not going to get a visible reaction.